Alright, so keep in mind, anytime we're factoring, we got to check for a greatest common factor, and we have to try to use MAM. So when we check for a GCF of 10x squared plus 13x minus 3, you're not going to find anything that every single term is divisible by, so then we can jump in and try to use MAM. So we'll label the first term M, the second term A, and the third term M. Then we'll make our box over to the side. In the top left box, we're going to put what we get when we multiply the m's together. So it's going to be 10 times negative 3, so negative 30. And our a on the bottom is going to be 13. So we've got to find two numbers that will multiply together to get negative 30 that also add together to get 13. So those two numbers are going to be 15 and negative 2. Alright, so with those two numbers, you're going to create two fractions using the first m. Okay, so remember that the coefficient of 10 is going to stay 10 with both fractions, but the variable and exponent are going to get split in half, x and x. So then on the bottom, we'll put those two numbers that we just came up with, 15 and negative 2. Then we have to reduce the fractions if they can reduce. 10 over 15 can reduce down to 2 over 3. And 10 over 2 can reduce down to 5, but we have to keep it as a fraction, so I'm going to keep it as a 5 over 1. Also remember that that negative on the bottom has to stay on bottom because eventually that's going to be a minus sign. So now that we've reduced these fractions, the first binomial is going to be 2x and 3, 2x and positive 3, so that would be 2x plus 3. And our second binomial is going to be 5x and negative 1, so we'll write that as 5x minus 1. And then keep in mind, after you've done this, you can use FOIL and see if you actually get back to where you started, and you would if you multiplied that together. If you look at the second one though, again, always check for a GCF and try to use MAM. You are going to find a GCF of 6x squared plus 9x minus 6. And that GCF is going to be 3. So once you take the 3 out, you would be left with a 2x squared plus 3x minus 2. Okay, so there is a GCF, but we still have to try to use MAM. And we're going to use MAM on that quadratic expression that remains, just this part inside the parentheses. So this is M, this is A, and this is M. And then we'll create our box over to the side. In the top left, we'll multiply the m's together. 2 times negative 2, so negative 4. And our a on the bottom is going to be 3. So our two numbers that are going to work are going to be positive 4 and negative 1. Alright, so then we'll take those two numbers and create two fractions using the first m. Keep in mind the coefficient's going to stay with both of them, but the variable and exponent's going to get split in half to x and x. And then on the bottom we'll put 4 and negative 1. Alright, so then 2/4 is going to reduce just like on the last problem to 1/2. 2 over negative 1 can't reduce, so then we'll write each of these as a binomial. The first binomial is going to be 1x and positive 2, so x plus 2. And the second binomial is going to be 2x and negative 1, so 2x minus 1. And then of course you can use FOIL again to check and make sure that these two binomials do actually multiply together to get your original expression. Alright, so if I did that, I would find, hey, those don't actually multiply together to get that because I'm being a doofus and I left the GCF of 3 off. So anytime it says factor completely, that's a pretty good clue that there's going to be a GCF and you're going to be able to use MAM.